Hey there, today we're going to learn how to find the GCF of monomials. So first off, we need to talk about what a GCF is, and it stands for the greatest common factor. And the greatest common factor, basically what we use that to do is we divide both the monomials by the same GCF. Okay, now the best way to see how this works is we're going to take a look at an example. So in this first example, it says, find the GCF, so we'll find the greatest common factor of these two monomials. They're both monomials because they're just one thing, one cluster. Now, some people get a little intimidated by these clusters, but we're going to look at the numbers first. So we're going to look at that 18 and that 9. And what we want to know is what can we divide by both of them and still end up with whole numbers? Well, I can divide both of them by 3, but the GCF says we want the greatest number we can divide by both of them. And I can tell that this one is going to be 9 because 9 times 2 equals 18. And so if we divide both of them by 9, we'd end up with leftovers. After we divide, we'd end up with a 2 because 18 divided by 9 is 2, and 9 divided by 9 is 1. So we have leftovers of 2 and 1. But we also have these x cubes here, x to the third power. And so what we also notice is we can take out an x to the third power out of both of them because they both have an x to the third power. And so we would be left with 2 and 1 as our leftovers, and making 9x cubed our GCF. So remember, GCF is the largest number that we can divide by both of them and end up without any decimals. So, number 2, when we look at our example here, we have 5x squared and 15x. If we look at the numbers first, I can take a 5 out of both of them. Now, I'm going to end up with leftovers. And my leftovers in this case are going to be 1 and 3. However, you notice that this time the x's are not the same because we have an x in both of them, but in this one we have 2 and in this one we have 1. So if we wanted to take the same amount out of both of them without overdrafting, without taking out too much, then if we try to take out 2, we'd take out too much. So we can only take out 1x from both of them. So our leftover is going to be 1 and 3, except this one is not just 1, it's 1x. This one, the x's cancel out, and we're left with just 3. So our GCF, just a reminder on this one, what did we divide both of them by? 5x. When we look over here at this one, we have 30 and 100. I'm not going to worry about the m's first. I'm going to say, I think I can take a 10 out of both of them. If I do that, I'd end up with 3 m to the third and 10 m to the 7. So right now we're saying our GCF is 10. But we notice that we can also take out the m to the 7 and the m to the 3. We can take some m's out. We can't take 5 out or 7 out because we've only got 3 in this one. So just to be fair, we can only take the same amount from each one. So we can take out an m to the 3. What's that going to leave if we take an m to the 3 out of both of them? Our leftovers are going to be 3 and 10 m to the 4th. As we look at number 4, focus again just on the numbers first. What can I take out of both of those? I actually can't tell, but I think at least I can tell they're both even. So I'm going to take out a 2 out of both of them. And that would give me 12 n cubed and 21n. And I notice that I can still take out something out of both of them. They're not even anymore, but this one I can take out a 3, and this one I can take out a 3. That leaves us with 4, and this one leaves us with 7. we can take out not 3 n's, but only 1 n out of both of them. So we'd be left with 2 n's, or n squared, and then this n would go away, meaning our GCF would be 3n. Now, we keep on mentioning the leftovers because we're going to use them a little bit more in the next video. But let's look at one last challenging common factor. We're going to see if we can take a common factor. I want you to notice that there are 2 variables here. But again, we're going to look at the numbers first, and then we'll look at the x's and then the y's. So first, the 12 and the 18. This one jumps out at me. I think I take a 6 out. So if I take a 6 out of both of them, my leftovers would be 2 and 3. Now let's look at the x's. Can I take any x's out? Well, I have an x over here. I have x to the first power, and I've got x to the second power. So the most I can take out is just an x to the first power. What would that leave me with? Well, this one over here would cancel out. So I wouldn't have any x's over here with my 3. But this one, I've still got one more x. Now, lastly, we're going to look at the y's. I do have y's in both of them, so I can take out a y out of both of them. But that cancels out here. And just like the x's in the last one, I can take out a y, and I'm still left over with one y left. So my leftovers are going to be the 2x and 3y. And our GCF, what did we take out of both of them? Well, we took out a 6xy.